Betelgeuse or insect Jew, a red monster star on the verge. Creepy crawly Jew, a red Goliath star, is a galactic wonder. In the event that you put it where the sun is, it would reach out to the circle of Jupiter. It's huge. It's entirely shaky, and it's going to detonate. Prepare for a vast calamity of never-before-seen scale. Betelgeuse, the red Goliath star on the edge of our world, is conveying alarming messages through space. Stargazers have tracked down something profoundly upsetting about this monstrous object. Utilizing the James Webb Space Telescope, eminent researcher Brian Cox has given an intense admonition. The question that continues to come up is, are we going to observe a cosmic explosion blast that will change the night sky until the end of time? The puzzler of Betelgeuse is its relationship with the endlessness of the universe. Stars are conceived, live, and die in astonishing ways. As of late, one star has grabbed the eye and worry of both space experts and the overall population. Betelgeuse, a red super-Goliath star in the heavenly body Orion, is amazingly monstrous and antiquated. Its special rosy variety and fluctuating splendor have for quite some time been charming. Yet late occasions have uplifted interest in this enormous monster. As we find out more about Betelgeuse, we are very nearly a potentially great event in its history. But what could these changes in insect juice mean? Are we seeing the start of an infinite scene on an unfathomably gigantic scale? Bug juice's colossal size and life cycle make it a heavenly Goliath roughly multiple times bigger than our sun. Its size is nearly outside human ability to grasp. Envision a star so monstrous that, if it supplanted our sun, its surface would reach out past Mars' circle, encompassing Mercury, Venus, Earth, and Mars. This monster size not only shows the actual loftiness of Betelgeuse, but also shows its stage in the heavenly life cycle. As a red Goliath star, Betelgeuse is approaching an incredible finish, extending and cooling subsequent to depleting the hydrogen in its center and combining helium. What about Betelgeuse's age? This star is assessed to be among 8 and 8.5 million years old. While generally youthful in human terms, it is antiquated in heavenly terms, north of millions of years. Insect juice has gone through emotional changes, developing from a hot blue star to the red Goliath we notice today. It is now in its last stage as a red Goliath star. Like Betelgeuse, stars change throughout their lives due to the continuous tensions of atomic combination and gravity. Another trademark that makes the phase of Betelgeuse stick out is its special rosy variety. Its red tone emerges from its cooler surface temperature, contrasted with different stars like our sun. Splendor changes and verifiable records show that the sun's surface is around 5,500 Kelvin, while Betelgeuse's surface is around 3,500 Kelvin. This cooler temperature permits Betelgeuse to emit light at frequencies that make it seem red. However, this tone is more than simply an appearance. It reveals data about the star's physical state and the cycles happening inside its immense vaporous volume. The way that Betelgeuse's tone has changed over time adds to its secret. Verifiable records from Roman and Chinese periods show that Betelgeuse was yellow close to 1,000 years ago. By the 9th century, Arabic cosmologists noticed its red variety. This change over the course of mankind's set of experiences isn't simply a verifiable commentary. It implies the star's development. One more fascinating part of Betelgeuse is its changing brilliance. It is a semi-normal variable star, meaning its brilliance vacillates occasionally. This musical diminishing and lighting up has dazzled researchers and stargazers for hundreds of years. Commonly, Betelgeuse goes through a multi-day cycle and a more extended 5-year cycle. As soon as 1836, Sir John Herschel recorded these cycles, and native people chronicles might go back much further. However, what genuinely makes Betelgeuse strange isn't just its splendor changes, but their abnormality. Dissimilar to many stars that shift in brilliance normally, Betelgeuse occasionally goes amiss from this example, recommending complicated and less understood processes within its tremendous structure. Unforeseen perceptions and later advancements. As of late, cosmologists and stargazers worldwide were stunned to notice a sensational and startling change in Betelgeuse's appearance. This extraordinary diminishing has raised various different kinds of feedback. This is now known as the extraordinary darkening. In late 2019, the red Goliath Betelgeuse, one of the most brilliant stars in the night sky and a noticeable feature of the group of stars Orion, began to diminish bafflingly. The star was darkening so quickly that it started losing its light at a pace of 0.01 magnitudes each day on average. By February 2020, it was at its dimmest, causing observing challenges. Betelgeuse, which can generally be seen with the bare eye even in regions with significant light pollution, turned out to be much fainter, and even casual eyewitnesses could see the difference. The time oddity, however, complicates observing Betelgeuse's activities, since light takes such a long time to contact us. At the point when we notice a star like Betelgeuse, we are not seeing it as it is now, but as it was in the past. For Betelgeuse, the light we see today left the star nearly 1,000 years ago. For what it's worth, it is around 725 light-years away. This delay makes predicting and checking quick changes in its behavior testing. Observations and examinations by researchers have shown that the Betelgeuse diminishing occasion highlighted the challenges of ongoing sky perception and our limited comprehension of the huge and secretive domains of existence they possess. Andrea Dupree, Deputy Director of the Center for Astrophysics at Harvard and Smithsonian, and her group closely monitored Betelgeuse's divine show as a feature of a 3-year study to follow changes in Betelgeuse's outer atmosphere. They utilized the Hubble Space Telescope to notice the huge star. These observations provided new insights into how a variable star like Betelgeuse works. Variable stars routinely extend and contract, causing changes in their splendor. Scientists were able to inspect the layers above Betelgeuse's surface, warmed somewhat by the star's twirling convection cells. Thanks to Hubble's aversion to bright light, further examination of Hubble spectra taken at various times in 2019 and 2020 revealed the development speeds in Betelgeuse's upper atmosphere and the discharge of material and its results. The spectra were basically made out of magnesium, showing that material was moving from Betelgeuse's surface into its atmosphere at about 200,000 miles per hour. This hot, thick material eventually traveled thousands of miles away from Betelgeuse, forming the dust cloud that diminished the star during the 3 months of the explosion. Dupree and her group assessed that about twice as much material as expected was launched from Betelgeuse's southern hemisphere. While all stars lose mass over time, Betelgeuse's mass loss was especially remarkable because it happened at a much quicker rate than the Sun's. Stargazers discussed whether this event could signal a looming cosmic explosion, given the size of the mass delivery and the ensuing darkening being just about 725 light-years from Earth. Insect Jew adds to the interest, as any such blast would be apparent from Earth and offer an uncommon opportunity to notice a cosmic explosion up close. Speculations about Betelgeuse's future. In any case, the inquiry remains, what does this diminishing mean for Betelgeuse's future? Is it an indication of an unavoidable cosmic explosion? Or is it simply a one-time occasion in the star's long and complex life? A few hypotheses have been proposed to make sense of this rapid transform. One well-known hypothesis suggests it was a forerunner stage in the cosmic explosion process, gaining momentum due to the belief that Betelgeuse is approaching the finish of its life. Another normal hypothesis posits that dust, possibly from the actual star, was blocking our view. It is known that Betelgeuse and other red supergiants shed material, which could gather into a dust cloud sufficiently thick to darken the star's light. A third hypothesis examined how changes in the star's photosphere, the visible external layer, could influence its apparent brilliance. This puzzle was handled utilizing a blend of observational procedures and top-to-bottom investigation. Spectroscopic examinations and discoveries showed that Betelgeuse's effective temperature dropped, suggesting that the star might be diminishing due to a large dark spot on its surface. The fact that Betelgeuse's temperature decreased by somewhere around 170 Kelvin around the time of the diminishing supported this thought, indicating tremendous changes on the star's surface. In the end, the Hubble Space Telescope, mankind's guard dog in space, helped us comprehend what was occurring with this strange occasion. Hubble's perceptions showed that the diminishing of Betelgeuse was likely due to a lot of hot matter being launched out into space. This material formed a dust cloud that obscured a piece of the star's surface, lessening how much light was reaching Earth. The dust cloud was accepted to comprise extremely hot plasma that emitted from a huge convection cell on the star's surface. As this plasma traveled through Betelgeuse's hot atmosphere to cooler external layers, It formed dust grains that made a cloud hindering light from about a fourth of the star's surface. The effect of the catapulted material, Hubble's bright light spectroscopic examinations, which began in January 2019, were significant in sorting out the occasions paving the way to Betelgeuse's diminishing. These examinations identified thick hot matter traveling through the star's atmosphere long before the diminishing. A few ground-based telescopes likewise noticed the star's splendor decline in December 2019, with the Hubble perceptions substantiating the discoveries and providing further insights into the catapulted material. The disclosure that Betelgeuse was losing material at a much quicker rate than recently suspected prompted the acknowledgement that this rapid mass loss could influence how we might interpret heavenly development, especially in red supergiants. It is crucial to understand that Betelgeuse isn't the only star going through such sensational changes. Other historic supernovae, such as SN 1054 and SN 1987A, have provided significant insights into how stars pass on and how new cosmic elements form. These previous occasions have helped shape our understanding of heavenly passings and their impacts on the encompassing space. For example, SN 1987A, which happened in a neighboring galaxy, offered a close perspective on a cosmic explosion and its result. Such cosmic explosions contribute to the grandiose cycle by scattering heavy elements and impacting star development potential. If Betelgeuse ultimately turns into a cosmic explosion, it would create a fantastic light show visible from Earth. The blast would be more brilliant than the moon and could even be seen during the day. Such an occasion would provide a unique opportunity to study the last phases of a massive star's life, as well as the development of enormous structures and the spread of heavy components across the universe. In spite of the sensational nature of a cosmic explosion, the distance between Betelgeuse and Earth provides an inestimable safeguard, ensuring that such a blast is probably not going to directly hurt our planet. The insights gained from observing Betelgeuse's inevitable change will continue to advance our understanding of heavenly development and grandiose peculiarities. The role of red supergiants in heavenly advancement. Red supergiants like Betelgeuse are critical to how we might interpret heavenly development. These stars represent the last phases of a massive star's life cycle before it undergoes a cosmic explosion. Their tremendous size and relatively short life expectancies make them amazing laboratories for studying the end periods of heavenly advancement. Red supergiants are vital in understanding how massive stars evolve, as well as the cycles leading to their explosive deaths. These stars have a colossal effect on their surrounding conditions. The energy they discharge in their last stages contributes to the blend of heavy components that are fundamental for the development of planets and life as far as we might be concerned. Heavenly nucleosynthesis and heavy component development. The course of nucleosynthesis in red supergiants involves the combination of lighter components into heavier ones during their lifetimes. These stars intertwine hydrogen into helium and later helium into carbon and oxygen. When the star reaches the end of its life, it endeavors to combine considerably heavier components. This process results in the creation of components like iron and nickel, which are then scattered into space during the cosmic explosion. These heavy components advance the interstellar medium, contributing to the development of new stars, planets, and even life. The study of red supergiants like Betelgeuse assists researchers in understanding the processes that produce these significant components and their distribution throughout the universe. Implications for cosmic science. The death of a red supergiant and its ensuing cosmic explosion has significant ramifications for vast science. When Betelgeuse eventually detonates, the heavy components it has blended over its lifetime will be dispersed into the system. This distribution of components plays a key role in the chemical evolution of the universe. It impacts the structure of new stars and planetary systems, as well as the potential for life. By concentrating on these cycles, stargazers gain insights into the history of our world and the circumstances that led to the formation of nearby planetary groups and habitable planets. Observational methods for cosmic explosion research. Understanding cosmic explosions and their forerunners involves a range of observational methods. Telescopes observe various frequencies of light, like optical, ultraviolet, and X-ray telescopes, providing valuable information about these vast events. The James Webb Space Telescope, for example, has advanced our capacity to notice far-off and faint cosmic objects, offering exceptional details about the beginning phases of heavenly advancement and supernovae. Ground-based telescopes also play a critical role, providing continuous monitoring and contributing to our understanding of variable stars and supernovae' influence on star-forming regions. The blast of a red supergiant like Betelgeuse has massive consequences for its surrounding star-forming areas. The shock waves from a cosmic explosion can trigger the formation of new stars by compressing nearby gas and dust. This process, known as triggered star formation, can lead to the formation of new heavenly systems in the aftermath of a cosmic explosion. The connection between the shock wave and the interstellar medium also contributes to the dynamics of the cosmic ecosystem, affecting the distribution of matter and energy throughout the universe.